Hello students, today we learn about the wear tooth load for worm gear. This is the second criteria in case of worm and worm wheel, that is wear tooth load. The limiting or maximum load for wear, that is WW, is given by WW is equal to pitch circle diameter for gear into face width into load stress factor. This K is also called as material combination factor. This load stress factor or material combination factor we get from this table. If if we observe this table, the headings becomes materials for worm and worm gear, then load stress factor K. This is in Newton per mm square. If worm is steel, which is having BHN value is 250 and worm gear is phosphorus bronze, then K is equal to 0.415. If worm material is hardened steel and worm gear is cast iron, then K is 0.345. If worm is hardened steel and worm gear is phosphorus bronze, then K is 0.550. Worm is hardened steel, worm gear is chilled phosphorus bronze, and then K is 0.830. Worm is hardened steel, worm gear is antimony bronze, then K is 0.830. Worm is cast iron, worm gear is phosphorus bronze, then load stress factor K becomes 1.035. This K values which is related to lead angles up to 10 degrees. If the lead angles increases, or if lead angle is between 10 degree and 25 degree, these values of K should be increased up to 25%. For lead angles greater than 25 degree, increase the value of K by 50%. So according to the lead angle, we change the load stress factor. So this is about the wear load. In case of worm and worm wheel, as speed reduction ratio is very high, so it creates a lot of heat. So it is very important to know what is the heat generated and how that heat gets dissipated. In the worm gearing, the heat generated due to the work lost in friction must be dissipated in order to avoid the overheating of the drive and lubricating oil. The quantity of heat generated, which is given by Qg, is equal to power lost in friction in watts, which is equal to P into 1 minus eta. This is equation number 1, where P is called as power transmitted in watts. Eta is efficiency of the worm gearing. The heat generated must be dissipated through the lubricating oil to the gearbox housing and then to the atmosphere. The heat dissipation capacity depends upon the following factors. First is area of housing, which is indicated with capital A symbol. Second is temperature difference between the housing surface and the surrounding air, that is T2 minus T1. And third is conductivity of the material, that is K. Mathematically, the heat dissipated capacity, that is QD, is equal to the area of housing A into T2 minus T1, that is temperature difference, into conductivity of material, that is K. This is equation number 2. Now from equation number 1 and 2, from these two equations we can find the temperature difference, that is T2 minus T1. The average value of K may be taken as 378 watts per meter square per degree Celsius. So in this way we discuss about the two topics, that is worm tooth load for worm gear and heat generation and heat dissipation capacity in worm and worm gear. So here we stop. Thank you.